Alright, so we're going to start doing wave properties now, and we're going to break this up into several different smaller videos rather than one really big long video because we've got a lot to cover. And we're going to start with reflection, and in particular we're going to restrain ourselves to reflection from a plane mirror, like a plane, a flat mirror. The things we're going to have, some of the properties when we have this reflection is that there is going to be no change, sorry, that's the word change, no change in frequency. So normally the frequency of a wave pretty much always matches the source. If it changes mediums and it changes speed, then the wavelength will adjust to keep the frequency the same. Much like if you have a bunch of cars that are driving slowly and then suddenly they get to a line or something where they can drive fast, then the cars will spread out as they go faster. So you have a bunch of slow moving cars and they suddenly turn into fast moving cars or faster moving cars, and they get spread out. And what happens is still here the separation changes, so essentially the wavelength changes, but the frequency stays the same. So if you represented this like a wave, it would do something like suddenly stretch out. But because it's also traveling faster, even though it stretches out like this, the frequency will stay the same. And so that's when it changes medium. And since we have a reflection occurring, we're not changing medium. So if it reflects off a surface, it's coming from like air or a vacuum and reflects off a surface, it's staying in the same medium, so there is no change to frequency. Since it's staying in the same medium, there will also be no change in the speed of the wave, like there would be as it changes mediums. And since there's no change in speed and no change in frequency, there's also going to be no change in wavelength. This will not be true when we get to the next section, when we talk about refraction instead of just reflection. Okay? So we have two main types of reflection we are interested in: diffuse and specular. And we're mostly going to be interested in this specular kind. So let's draw these out. Let's say we have over here we have a nice plane mirror. That's supposed to be a nice flat straight line. I'll try and save it by making it thicker, but anyway, we have a plane mirror sitting there, and we have a bunch of light coming in that's all nice and ordered. In other words, it's all parallel, and this parallel light comes in like this. And what happens is when this parallel light comes in, it's a specular reflection if it stays in that same order. So if it comes in parallel, it's going to leave and reflect parallel. On the other hand, you can have what is known as a diffuse surface, right? So something kind of like rough and jaggedy like this. And light that comes in parallel, let's see, comes in this way and comes in here, and it comes in all parallel, is not going to reflect in the same ordered mannered way. So this one can reflect up this way, this one can go back that way. So we have all these lights coming in. Probably should have drawn the arrows before I started drawing the rest of it. But this one will reflect that way, this one will reflect that way, this one comes in and reflects off that way. And so the light that we had that was ordered and parallel on its way in is diffusing. It's jumbling all up as it reflects back. This kind of reflection is what you get off of most surfaces, your clothes, your shirt, most doors and things like that. Surfaces that are not perfectly smooth, and it gets all jumbled up, and you can't see a reflection, a nice reflection in it. If you looked in it, you don't see your own face. Over here, this is specular. This is what you get off of nice smooth surfaces, like a mirror, a flat mirror that you have like in the bathroom or something, or off a newly waxed and polished car or something like that. You get this kind of specular thing where you can see nice reflections of things in it. Determines if it's specular or diffuse. So we have one big rule for reflection, and that is that an object reflecting pretty much off of any surface we're interested in, if we look at it, it's going to bounce off at the same angle it came in at. Kind of like if we bounced a ball off a wall, it would go in and bounce off at the same angle like that. It would go in, hit, and bounce off. So what we're going to do is we're going to measure the angle that it bounces off to from the normal. So this is our mirror surface. This is our reflective surface. So this is reflective, and this is the normal. Okay? And light is going to come in at some angle, and it's going to hit this. It'll be a little easier if I draw it backwards. So the light is going to come in this way, so in comes my nice, oops, that's just getting awful. In comes my nice straight line light, and then it's going to reflect off, that one was much straighter, at the same angle. And the angle it bounces off at is going to match the angle it came in at. So this is the angle it came in at measured from the normal. We're going to call that the incident angle in theta I, and this is going to be the reflected angle, so theta R. And what we have is that theta I is going to equal theta R. And that was true up here. If you go up here and you draw in normal lines here, all of these normal lines are all going to be parallel, which means that as they all come in at the same angle, they're going to be bouncing off at this angle. So this angle is the same as that little angle in there. And the same thing over here. These angles, they're all going to be the same. So it stays orderly because all the normal lines are orderly because this surface is flat. Over here, the normal lines are all in different directions. If I look here, this is normal to the surface, and then over here, this is normal to the surface, and over here, this is normal to the surface, and then over here, this is normal to the surface. So this angle matches this angle, but it doesn't match these two angles over here. Those are different angles because it had a different normal, so it hit the surface at that point at a different angle. So if you came in to like this spot and you drew in a tangent line to the mirror at that point, then this normal would be perpendicular to it. Drew in a tangent over here, it'd be like that. You drew in the tangent like right there at that little spot or over here where it was nicking, and then the normal would be perpendicular to that, and it would still follow this rule. It's just that every bit of light that hits is hitting the mirror at a different angle, so they all get jumbled up even though they all came in at the same angle. Okay? Next thing is then how do you see this actual image that's in there? And so let's talk about when you just look in a normal flat mirror that's on the wall. So let's say we have a mirror here. This will be our mirror. Okay? So here's the mirror. And then we're going to put something over here that just represents what we're looking at. We're going to go ahead and say, all right, here's the mirror, here's the ground or something. And then we're going to say, all right, here is you standing there looking in the mirror. Okay? Well, what happens? Well, light leaves you in a bunch of different directions. Light goes straight away from you. Light comes down at this angle, light comes up at this angle, and it just goes out in all directions. We can't draw in every single direction it goes because really there'd be way too many. We'd have lines going in all directions. But this first light ray that comes in horizontal like that is going to come in horizontal, and it's just going to, its angle that it comes in at is 0, which means it's going to bounce back at 0 relative to the normal. It comes in along the normal, it goes back out along the normal. This one comes in at an angle to the normal, and it's going to bounce back out to the normal. And then this one's going to bounce back out, staying at that same angle to the normal. Okay? And when you see something, you don't see where it actually is, you see where it appears to come from. And if we trace all these lines backwards through the mirror like this, and hopefully this will make sense when I finish, bring that one straight up and bring this one straight over, we find that they all, oops, that was not very good of me. I got a little wonky there, sorry. Let me try that again. My picture may not be the best ever, but you come along and draw this, we find that they all match up at the same spot. And if it was all coming from, say, like, your forehead here, then that's where your forehead would appear to be. Your forehead would appear to be right there, And then if we went through and did the same thing with your chin, then that light would come over and it'd make your chin and this light would bounce up and stuff. And if we did this same exact thing, they'd all trace backwards through and we'd be able to make another version of you here. And so the light coming to you that would bounce back from the mirror that you'd be seeing would appear as though it was coming from the back side of the mirror, right? So in other words, if we just took an identical twin of you and put them dressed just like you and stood them the same distance behind the mirror that you were, and then we removed the mirror, it would look the same to you. Okay, it wouldn't change. So if you were standing, and I know my picture didn't turn out right here, but let's say you were standing whatever distance this is from the mirror, some distance x, then your image would be that same distance, or appear to be the same distance behind the mirror, right? You see something and you see where the light came from. If we can bounce the light off in directions and you trace it backwards, then that's where the light appears to be. So in other words, if this person was standing here, your identical twin was standing here and there was no mirror here, then what would the light from that person do? What would it do? It would come straight across into your eyes and it would go straight up this way and it would go straight down and it would follow these same exact paths that the light reflecting is following. So to anybody standing over here looking in the mirror, then they see something standing here. It's the exact same situation on the left side here, as though the mirror wasn't there and we just had all the same objects in mirror image just all over here. Okay, hope that makes some sort of sense to you. And then there's one more I wanted to kind of show to you about how this can flip objects over. And so let's say we have a mirror. I'm going to make the mirror blue this time. That probably would have been better. It looks like more of a reflective thing. So there's the mirror. And what we're going to do is say we have a little candle or something up here. And a little candle right there, a little flame on it. And then you're going to be over here, this is your eyeball, I guess, looking at it, right? Side view of your eyeball. And you're looking at this. You're looking down here at the mirror. Well, light coming from the top of the candle will come down here, and then it will bounce off at the same angle and go into your eye. That was, again, let me fix that. So, and comes back over here to your eye. Light coming from the bottom of the candle, maybe I'll do that in green. Light comes from the bottom of the candle and bounces up like this, and it goes into your eye. And again, you see what would create this light anyway. So if we trace this one backwards, the same distance, because you can see how far away it appears to be. So we trace that one kind of backwards, and we trace the red one kind of backwards. They're going to cross like that. And so what you end up getting is you get the bottom of the candle here and the flame of the candle up here. And you would get something like that. So it's kind of like if you took in a mirror and you pointed your finger at the mirror, right? It would look like your finger was pointing back at you. So if the bottom of the candle is pointed at the mirror, then the bottom of the candle is pointed at the mirror from the other side. It does that kind of mirror imaging. Okay? I think that's pretty much everything for reflection that we need to know at this point. So we'll move on to the next video, which will be refraction.